Hi Chem Peeps. This video is part of our thermodynamics unit, and I am going to talk about Gibbs free energy. Gibbs free energy takes into account the enthalpy, the change in heat, the entropy, the change in order, and the temperature of the reaction. Gibbs free energy is really the only way to determine if a chemical reaction for the conditions it's at will be spontaneous or not. There's two ways to calculate Gibbs free energy. So you can see here I have two separate ways. The second way here is similar to what we did for entropy and enthalpy. It's the products minus the reactants. And so, yes, there are charts in the index and in your chapter on thermodynamics that list the Gibbs free energy for different substances at room temperature for 1 mole. And you can do products minus reactants. For the examples that I'm going to be doing, since I've done products minus reactant problems for entropy and enthalpy, I am going to use the other reaction. The other reaction, Gibbs free energy, which is delta G, is determined by taking the enthalpy, the change in heat, the temperature measured in Kelvin, and the entropy of the reaction. And we can calculate if something is going to be spontaneous or not by the value that we get for delta G. If the delta G is negative, then the reaction is going to be spontaneous. If the delta G is positive, then the reaction is going to be non-spontaneous. And if you should get 0 for delta G, then the reaction is going to be at a chemical equilibrium, which will go into your chapters on equilibrium, which I have yet to cover. So something I want to point out as you're doing these problems are the units. Pretty important. So if we look at the charts in your book, Gibbs free energy is measured in kilojoules. Enthalpy is measured in kilojoules per mole. Okay. Temperature is measured in Kelvin, and entropy is measured in joules per mole K. Now, that's going to be a problem when we go to solve problems, because we really, ideally, want all of the energy units to be in kilojoule. So we're going to have to deal with this over here. Typically, I tell my students, when I'm doing the notes on this chapter, that delta G is equal to the delta H minus the temperature in Kelvin times the delta S, and then I always tack on times 1 over 1,000. And this 1 over the 1,000 on the end here will convert joules into kilojoules, and that will be so very important when we're solving our problems. So let's look at the next video and do some sample problems for finding Gibbs free energy. You can find me on TikTok and YouTube at Chem's Chem Chat.